Hi. So once again, let us take another example regarding the integration of the combined functions. So last time we discussed about the type 1 wherein we have the combination of tangent and u, secant and u du, wherein we say that the m and n are both positive odd integer. For example, tangent is raised to 3 as well as the secant is raised to 3. Okay, so they are both odd. So this time, let's have another example regarding the type 2, which is the n is a positive even integer. So say we need to evaluate the integral of tangent 8x secant squared x secant 4x d of x. Okay, so as you notice, if we analyze this, the m is 8 and the n is 4. So this is under type 2, which is the m and n are positive even integer. So they are positive and they are even. 8 and 4 are even integer. Okay, so if we have a type 2, we need to use this derivative and the identity. Okay, so our technique, if we have this form, is that, or we have this type, we need to isolate this, the secant squared u du, and this will serve as the derivative of the tangent. Okay, so our technique is first to isolate the secant square u, because this will serve as the derivative of the tangent. Once again, if we review our integral, the calculus 1 or the differentiation, the derivative of tangent u is secant square u. So our technique once again is to separate or to isolate this secant square u du here. And then if we already separate this or isolate this, we can now use the trigonometric identity in order for us to express these terms in tangent. Okay, since we will going to use tangent as the this tangent, that's why we need to express our whole term as tangent. Okay, so let's try. So we say we need to isolate this secant squared u du, because later on we will use this as the derivative of tangent u. Okay, so isolating the secant square, we have tangent 8x, and then factor out the secant square u, so we have secant square x, and then we need to multiply another secant squared x here to complete our equation. Okay, we have the tangent x raised to 8, we have secant fourth, which is, we have here secant squared x, which is equal to secant fourth x. Okay, and then our d of x. Then right after that, our technique is to, since we say that this is now the derivative of our tangent, so we say that the derivative of tangent is secant square u du. So this is now the derivative of this tangent. So what we have left here is this term, secant square x. In order for us to convert this whole term in terms of tangent, then we need to use the identity, which is the secant square u is equal to tangent square u plus 1. So we have the tangent 8x, and then the identity of this is tangent squared x plus 1, then this term, secant squared x d of x. Okay, so let us review what we have. So we say for type 2 we will use this technique. We need to isolate secant square u du because this will serve as the derivative of tangent. That's why we need to convert all of our remaining terms in form of tangent. Okay, so we have tangent 8x, but we have here the secant squared x. In order for this term to be converted in terms of tangent, because we will need this one later, we use the identity, which is the secant square u is equal to tangent squared x plus 1. So as you can see, we have tangent here and the derivative of the tangent, which is the secant square x. Okay, then let's try to simplify this. We have tangent 8x times tangent squared. We have tangent 10x, because for multiplication we add the power. So we have 8 plus 2 is 10, and then plus this term, okay, which is tangent 8x, and then multiply to the remaining term, secant squared x d of x. Then right after that, as you can see, we have our term in form of tangent and its derivative. So its derivative is secant squared x dx. Okay, so we can now let u is equal to tangent x, and then the derivative of tangent x is this one, secant squared x d of x. So from that you can now easily see that we can now use the power formula, which is equal to, so this term here is also equal to tangent x raised to 10, right? So we have tangent x, which is equal to u. So we have u tangent x raised to 10 plus this one, u raised to 8, then our du, which is secant squared x dx. Right after that, you can now distribute the du. We have u to the 10 du plus integral of u to the 8 du. Then using a power formula, we have 8 to the 11 all over 11 plus u to the 9 all over 9 plus c. Then right after that, we need to replace back the value of our u, which is equal to tangent x. So where u is equal to tangent x, so we have tangent x raised to 11, all over 11 plus tangent x to the 9 all over 9 plus c, or you can simply say that we have tangent 11x all over 11 plus tangent 9x all over 9 plus c. So this is now our final answer.